Hi, this is Dan Petrock, and this is the solutions video for chapters 4, 5, and 6 in statistics, fall of 2012. Question 1 has probability questions. The first one is just trying to find the probability that someone did not have a job in their field. So if 61% is the probability that they do, 1 minus that is 39%. That's the probability that they do not. On B, it's asking what's the probability of randomly selecting 2 in a row that do have a job in their selected field. So one has a job in their field and, which means multiply, has a job in their field. So it's about a 37% chance. And then what's the probability of getting 5 in a row that do? So that's job and job and job and job. So we multiply all of those, so that's 0.61 to the fifth, which is about an 8.5% chance. On D, we want to find exactly 3 out of 5. That's a binomial. Either they did or did not find one in their field. So we use a binomial probability formula. So that's 5C3, which gives us all the different ways that could happen. And then I went 3 successes, so it's 0.61 to the third, and I went 2 failures, so it's 0.39 squared. So there's about a 35% chance that you'll get exactly 3 out of 5 that have jobs in their field. And then this question is, what's the probability that at most 4 out of 5? So that means 0 would be fine, 1 or 2 or 3 or 4. So you could do all those separately, but an easier way is just to take 1 minus the probability of the opposite. So the opposite of getting 4 out of 5, at most 4 out of 5, would be all of them having a job. Well, it looks like up here we already calculated. Here's the probability that they all 5 have a job. So we'd take 1 minus the probability that they all get a job, and that would be 4 or less. So there it is, 91.55. That's a complement. On 2 here, is it unusual to guess the birth year? And we're going to say no, because for something unusual has less than 5% or less than 1 out of 20, and usually you can look at somebody and be within a 20-year span of their life. So that's usually not unusual to guess their birth year if our threshold is 0.05. Would it be unusual to guess their birth month? Again, 1 out of 12 is not less than 0.05, so it's not unusual. And if they told you the month and year, would it be unusual to guess the day? And we're going to say yes, because even February has 28 days, and that's less than 1 out of 20. On 3, we've got a table here, and we're supposed to find some probabilities and conditional probabilities as well. So the first one, out of the 100 flights, find the probability that arrived on time. So on time was 68 out of 100, so 68%. And what's the probability that they was late or upstate? So we take all the late ones, which is was late was 32, and upstate, which is 40. So there's 72 flights, but we've actually counted these 15 twice. So we use A and B minus the intersection, so we minus 15. So that's actually 57 out of the 100 flights would be in one of those 2 categories. And then C, what's the probability that it was on time given it was with upstate? So which ones are both? Probably of A and B. So upstate and on time, there's 25. And now we're just comparing the second thing. Given it was from upstate, well, how many total flights are upstate? 40. So we know we're just going to look out of those 40 flights. So it's just 25 out of 40. And on D here, what's probably that the randomly selected flight was on time given it was with Podunk? So how many were on time and with Podunk? 43. And now we're just going to look at the Podunk flights, which is 60, which is about 72%. And then E, what's random? They were Podunk given it was late. So we want Podunk and late, Podunk and late. So that's 17. And it said given that it was late. So the question is how many late? So it's just going to be 17 out of all the late flights, which is 32. And number 4, we've got 4 good or 4 defective and 96 good. So there's 100 coils total. What's the probability that you get 2 good ones in a row? So good and good, and that's with replacement, so it's just the same. And this one is without replacement. So here's good and good, but now there's only 95 good out of 99 total. So it's just a slightly less probability. And odds is success over failure. So there's 96 successes and 4 failures. So it's the odds of picking a good one. And here's the odds of picking a defective. How many are defective? 4 compared to 96 good. So that's a little bit different. And 5, expected value for a life insurance policy. We use the expected value formula here. So pretty much you're saying, what's the probability that they pay out. So the probability that they pay out is 1 minus 0.9992, which is about 0.0008. And what happens is they get $90,000. So there's this, tens, hundreds, thousand, 8 out of 10,000 chance that they pay out. And then, but they for sure are going to buy the policy, which is minus 126. So the net for the insurance company, they get $54, or if you look from the consumer standpoint, they're losing, the expected value is a negative $54. And 6, this is that binomial probability formula again, exactly 4 out of 7. So there's the probability of success, which is 55%. So 7C4, that's all the different ways you can get 4 out of 7 correct, or 4 out of 7 bullseyes. And we want this to happen 4 times, 0.55 to the fourth, and 0.45, which is the probability of missing, happen 3 times. So it's about a 29% chance. And 7, how many 3-digit numbers can be formed using these digits? Well, the first digit, there's 7 that can be used. And repetition of digits, so the first blank is 7, the second one is 6, the third one is 5. So if you take 7 times 6 times 5 times 4 times 3 times 2 times 1, you get 210. So that's where that comes from. Oh, I'm sorry, just 7 times 6 times 5, because it's only a 3-digit number. So that's how you get 210. Sorry about that. All right, on 8, just look up 1.13 in your z-table, and there it is, 1.870, area to the left. If you want area to the right, you take a 1 minus, and if you look up 0.59 in your z-table, you get this 0.7224. 1 minus that is the area to the right. And then on 10, it's the area between, so you look up 0.92 in the z-table, and you get 0.8212, point up negative 0.92, and you get 0.1788. And to find the area between, you take the difference. So that's the area to the left minus this area to the left gives you the area between, which is about 64%. On 11, we draw a picture. It's teacher salary is normally distributed. Middle's at 550. Probability that somebody's over 575. So we just do our z-score, and you get 0.24. And if you look up 0.24 in your z-table, you get 0.5948, and we want area to the right, so we take 1 minus that. So it's about a almost 41% chance that you would find somebody that makes over 575 a week. For the second one is, what's the probability of a group mean? So that's a little different. Same kind of idea. We draw a picture. We want to say what's probably the group average is under 525. So again, 525 minus 550 over 105. But now, since we're looking at a group mean, we're using the central limit theorem, which means we divide by the square root of n. In this case, n is 9. So now we get a z-score of negative 0.71. Look that up in your z-table, and there you go. So it's a little different. Some people forgot to divide by the square root of n because we're looking at a group mean, not just one piece of data. On 12, again, draw your picture. We want to find off, essentially, what's the cutoff for the top 5%. So if you look on your z-table, for the top 5%, you're going to find 1.64. That's the top cutoff for the top 5%. So z equals x minus mu. There's the average, 98.2, divided by the standard deviation. So we just solve for x. So multiply by 0.62, add 0.982, and then we get 99.2. So essentially if somebody has a normal body temperature of 99.2 and they're in the top 5% of kind of normal body temps. And then on 13, they want to find out the cutoff for the bottom 25%. So draw your picture. There's the bottom 25%. If you look up for the bottom 25% in your z-table, you get negative 0.67 standard deviations. So we know the z, we don't know the score, we know the average, and we know the standard deviation. Again, solve, cross multiply by 8, add 34.6, and we get a score of 29.2 is the cutoff for the bottom 25%. And 14, this one you're trying to say, okay, we've got 2 tests, what's the equivalent? So this first one they scored 28, with an average of 20 with a standard deviation of 4.6. So you calculate that z-score, it's 1.73 standard deviations above normal. The question is, what is that equivalent score on this other exam? So we know the z-score is 1.74 because that's a standardized score. We don't know the specific score in this test, but we know the average and the standard deviation. Again, cross multiply those two, and add 69. So a score of 86.8 is equivalent to a score of 28 on the first exam. That's the same distance above the mean. On 15, We just want to say what's the probability of getting, that a mechanic takes over or less than 7.6 hours, and the average is 10.4. So we draw our picture, we draw a line, we shade, we find our z-score again, and it's negative 1.55. And if you look that up, that's about a 6% chance if you look up negative 1.55 on your z-table. And now if we're looking at what's the probability that the average for 9 mechanics is below that same picture, but we have to divide by the square root of 9, and now it's a very huge z-score. So the probability that you would get the average for 9 mechanics to be under 7.6 hours is pretty much 0. It's not even on our chart, so it's like 0.0000001. So very rare case. And that's it. So I hope this video helps, and hope it gets you ready for the final, and if this is a later semester, it gets you ready for the next exam.